So the 8086 emulator is the one that we're going to talk about today. So before we start doing that, I'll just give you some videos that I've created for you, and these videos are available on my YouTube channel named Shexa. So here are the links. Let me paste the links in the description there. Please confirm that you are getting the messages that I'm giving you. Thank you, Nyasha. Right, so here are the links. I think I've provided 1, 2, 6, 7 links. All right, these are the links for you, ladies and gentlemen. So you can access these videos at your own spare time. You watch them, and I'm sure that I won't spend additional time teaching what I've taught you already, and what I've provided is oral and video lectures. So those are the links to the YouTube channel, and this is the logo that you will see when you get to the channel, and the videos are available. Like, comment, share, and most importantly subscribe, because I normally upload videos on the channel and maybe fail to share with you, all of you, the links to these YouTube channels. So make sure you subscribe so that YouTube itself can recommend these videos for you. Right, let me share my screen so that you can see the application that we are talking about, and that is the 8086. So I would like you to confirm if you can see that, if you can observe changes on the screen. emu8086, this is the one. So I have already installed this this application. So when I open it, it will run like this. So let me remove this one and remain only with right. Please confirm that you are seeing my screen where I am opening the emu8086 assembler and microprocessor emulator 4.08. Arnold is on it, right? Thank you very much. So let's now talk about the interface. So when you open it the first time, you will observe this this welcome page, where you can see the button for creating new project, and here on code examples you have several code examples available. Somebody is saying please maximize your screen. Okay, that's fine. Let me try to maximize it. Right, are you seeing it clearly now? What happens when I maximize my screen is I won't be able to see your comments and other things. So if I ask you to confirm, you can orally confirm or say it using your microphone. So I hope I've helped you in visualizing these things. So new button is used to create a new project. Code examples, we'll look at this one. That's the first thing that we're going to look at. We have several examples, several projects available on code examples. And then we have a quick start tutorial. This quick start tutorial, it helps you navigate, or it helps you in describing the hello world code in assembly language, especially for 8086 microprocessor. That hello world, some of the commands they exist for other microprocessors, but For this lecture, we're going to focus on emu8086 microprocessor. And then if you have created some files, some assembly files earlier or recently, you can quickly access them using this button. So let's just click the code examples. You can see that we have hello world, code to add and subtract, code to calculate the sum, compare numbers, binary x, and so forth and so forth and so forth. And we have more examples. So we can open hello world. We can open hello world, and from this you can observe that we have a lot of text in our text editor here. But the text that is in green are just comments. These are just comments. Everything that is colored in green is comment, and the comments start with a semicolon. So these are the comments here. These are the comments. These are the comments here. So never mind about these comments, but you can read them and maybe get an understanding of what is being described in these comments. So I just go through this simple code, but on your own, what you can do is you can let me say new once again. Right, you see I now have a blank document. If you go on examples, you will see a list of examples here, one sample, and so on and so forth and so on. And if you want hello world, you still click on this one and open it. So you can observe that this code is different from the code that we have opened earlier in terms of the number of code and the number of the amount of text, the comments, and so forth and so forth. But functionality is just the same, is to say hello world, So if you do not understand all these things, you can just close this emulator and then go back to this code examples, hello world, right? But if you want to go through this hello world on your own, you can click on quick start tutorial. It will help you in describing this hello world code through all these instructions, where to start, and so forth and so forth and so forth. So I won't go through these steps. I'll just leave you these steps. I won't describe more. I'll just leave it here because everybody, I'm sure, is having access to this. You're having access to this. So right, instead of starting with a very big code, I will start with a simple code, a very simple code. Let me maximize so that everybody can see. Please confirm. Somebody is saying it's Adeline. He's saying I'm not having volume. Do we all have volume? Please confirm if you do have volume. I have it. Arnold is available. Nyasha is there. Yes. So please, Aline, you may check your your speaker or your headphones. Thank you very much. Thank you. Let's just create. Let's click on new so that we can observe what happens and the types of files that we can create. We have .com template. So by .com, it's more like a file extension. These are file extensions, or these are just templates that you can create your code with. COM, it's simple and tiny executable file format, pure machine code. So this is a simple description given by the emulator, but what a com file is, it's a file which combines data, code, and everything else is mixed up in a single file, or it's not partitioned. It's a single file, but the code itself is not partitioned. Like let me say, if you have programmed in C or in Java programming language, what you have been doing is you have defined variables. We have global variables, we have local variables. Where do you declare those variables? It's obviously on top. You define those on top or outside any method. That's global variables. And local variables, you declare them on top position of a method. That is, the method, the variables are declared first, so that when you need to access the named locations, that is the variables, what you will do is you will have declared it, so you will have something to refer to. So you cannot declare a variable after you've tried to use it. So you first declare it and then you use it. So that's what we do as well here. But with com now, it's all mixed up. It's all mixed up in a single file, and it's not partitioned. So that's a com template for us. You will see as we open the com template. Let's just open it and see. So you can see that it's just this or RG 100H, and then this RET, and we can put our code in here. That's the com template for us. And then if I want to create a new file and go to select exe template, this is an advanced executable file. It has got different sections. Let's just open it and see what is happening. So you can see that we have a data segment here at the top, and data segment starts here and ends here, and the code for data segment it's here. So here, that's where we declare our variables. So we have sections for data, we have a section for data, section for stack, and we have section for code. So this is the section for code. Since as you can see that here we have a comment which is saying add your comment, add your code here. So that's where you can add your code. But if you want to add more variables, you can declare them here. If you want to deal with the stack, you can add your instructions there. If you want to add the code, you know where to add it. That's in this section. You see it. So that's exe template for us. If you want something else, we have binary, we have boot. So let's just open binary and see what it is saying. You can see that we have binary, which has got all the registers. Everything that you want to do, you need to specify it. If it's if you want to deal with general purpose registers, here they are. Don't be surprised, we'll talk about all these registers later in this lecture, but it will be more like half theory, half practical, because we will just talk about them and you will see the contents of these registers and so forth and so forth. So we have a boot template as well for creating floppy disk boot records. Here you go. You see this is the template. All these green text, they do not change anything. It's just for the programmer. So this is the code, right? I think we are good with the first page or the welcome page. We are good with the welcome page. So let's now start some code. So what we want to do is we simply use the com template, and then which is the most simple one. This is the simplest one, right? With this one you can add your code here, but before we do add the code, new, we all know what new button is meant for. Open, you can open existing examples. We have seen that we have these examples, you can open them and see the code. Then here you can save, you can compile, you can emulate. You have your calculator here. This calculator is used to add, subtract, whatever, or perform all the mathematical operations that you can perform in decimal, in hexadecimal, in octal, in binary, signed, whatever, and so forth and so on. So this is our calculator. So if I want to add, let me just say hexadecimal values, let me just say a plus 10 e is equals to, I press enter. So this is the value, and I'm adding it in hexadecimal. And if I want to add binary values, I can do it as like that and press enter. You can see that this is the result. This is, it's in hexadecimal. Let me just convert it to that, then press enter. You can see that this is the result of subtracting this from that. This is the result. It's a word. I can convert it to say I want a signed, byte. So that's it. I can clear and do all mathematical operations that I want to perform. Then we have a converter. With this converter, you can convert from hexadecimal to decimal. You can convert to octal, binary, and so forth 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 and so on. So you can do many things. Here you can, I will just show you this. You can change the font size. You can change font. Here we have 12. I can increase it to 14, but I think 12 is okay with us, so I will leave it at 12. You can change all these other things, right? So that's the initial interface for you, ladies and gentlemen. I hope we are all seeing this and enjoying this. Nyasha is asking, is this emu8086 available on Mac OS? I think it's available. It's just that the process needs you to install some other applications first, so that it runs on top of those of that application. Right, so let's start writing simple instructions, so that this simple instruction is going to help us observing what happens when we write an instruction. Don't worry if you do not understand the instructions themselves. Just understand the concepts. What I'm saying is, this interface, this part, this section is meant for what, this area is meant for what, this item is meant for what. That's what we want to do today. And then later on another day, we will start to learn instruction by instruction. We learn the move instruction, we learn add instruction, multiply, we learn load effective address, load whatever. We jump instructions, we will learn all those instructions. But today we want to know how to emulate, how to run an instruction. So the first instruction that we're going to write today is a move instruction. I will describe what a move instruction is, so that you understand what we are doing. It's not that today we're going to deal with move instruction. No, we are just learning the move, so that you appreciate what is happening today. So the move instruction is written like this. You just say move without an e, and then you put space, then you put the destination. So let me write this as a comment first. Move instruction syntax. Right, so this is the syntax. You say move. So this is not case sensitive. By case sensitive, I mean whether if you write move in small caps, it's equal to move in capital letters. So if I say move, then I say destination. And destination can be a register, can be a memory address, and then I put source here. A source can be an immediate value, can be register, can be memory address as well. So that's the syntax. You see, you say move to destination from this source. So move value from source to destination, and source and destination are separated by a comma. Move instruction is separated by destination, is separated from destination by just space. Right, so let's now move a value. Let's move to accumulator register. So AX, that's an accumulator register. So we want to move a certain value to AX register. And what value do you want to move? 1, 2, 3, 4 H. And this is so important when we are programming in when we are programming for 8086 microprocessor. Decimal values, you can just leave it like that without an H. It's just a decimal value. Then if you put an H, it means it's a hexadecimal value. If you put a B, it means it's a binary value. If you put an O like this, it's an octal value. So here we want to deal with hexadecimal values. I will tell you why. I want to start with hexadecimal values because the microprocessor itself, it displays hexadecimal values. So the value that we're going to move, I want you to see the exact value, because if I say 1, 2, 3, 4, and if we check on in the accumulator register, you won't see 1, 2, 3, 4 because 1, 2, 3, 4 might have been converted to hexadecimal value. So let's work with this. So this is the simple instruction that we have. We are moving what? We are moving 1, 2, 3, 4 value into AX register. So that's the move instruction. So let's try to run it and observe what is happening. Let me confirm. Let me check whether we are still together or I am by myself. Right, are we there, ladies and gentlemen? Are we there? Please confirm. I've minimized so that I can read your comments, and if you can use a microphone, you can confirm. Still here. Thank you very much. Thank you. So let's try to emulate it. Let's now emulate our code. So what we do is we click on this green play button named emulate. We emulate, right? So we can observe that we now have these three interfaces. This one is showing us what? The original code, or the code that we have written in our text editor. And then here we are seeing what? The emulator. This interface here is showing us the microprocessor itself and all the things that are involved. They are being shown here, right? I will show you one by one. The screen for outputting is here. You can, at the bottom there, you can see that we have our screen here. Okay, let's close the screen. We have the source. This is the source code. You can see the source code. This is the one that you have put into the memory to be executed. And if you want to reset, you can click here. you can reset. You see that it closes and opens. And then if you want to observe or open auxiliary tools, you can click on aux. You can see memory, you can see ALU, you can see FPU, stop on conditions, symbol table, listing, and so forth and so forth. We'll open memory before we close for today. I will show you memory and other things you can experiment by yourself. Right, so you can see that we have yellow highlighting a color here, highlighting this instruction. So this yellow background, it highlights the next instruction to be executed. It highlights the next instruction to be executed. And you can see that from our emulator side, this is the code. Emulator side, you can see that we have the same code here on this side. You can have the every code that is going to be executed is going to appear here. And what code do we have? We have move AX1234, it's there. We have RET there, it's there. So that's it. So this is the next instruction to be executed, but we need to know the address of this instruction to be executed next. The address of this instruction to be executed next is stored in IP register, which is this one here. So the address of this instruction is 0100 in hexadecimal value. So the next instruction, so IP is instruction pointer. It points to the next instruction to be executed. It points to the next instruction to be executed. Right, so here are our registers. We have AX accumulator, base, count, DX, CX, IP, SS, stack pointer, stack segment, stack pointer, base pointer, source index, destination index, data segment, extra segment. So these are our registers. And these registers, each of these is of size 16-bit. Accumulator, base, address, register, counter. If you hover on each of these registers, it's going to tell you which, it's going to tell you the name of the register. So this data, code segment, instruction pointer, stack segment, stack pointer, base pointer, and so forth and so forth and so forth. So these are the registers that we have. So here is I've illustrated that we have memory, and next here we have variables. You can observe if you have declared any variable, it's going to be available here, but we didn't declare any variable, so we cannot see it here. But let me just declare one so that you can observe. You can observe. I cannot edit the code well in this mode, so I need to go back here. Let me declare a single variable defined byte called Shexa, and I'm going to give it value 1331. 1332 in hexadecimal. So that's let me emulate it and observe if I do not 8 bits. Okay, that's fine. 8 bits. Let me define it as word. Run it. Right, so if I click on variables, I now have this variable, and let me check. It's not appearing as a variable. It's okay. It's appearing as an instruction. Okay, that's fine. It's okay. I will show you when I declare a variable. Let me just remove this one and just close my emulator and then comment out this one and emulate it. So for variables, you can see them here. We will see if we start to declare variables, and then we have debug. You can debug and see all the registers available here and all the instructions that we have written. they will be available here. Now we have our stack. You can see the stack contents here. Stack contents. So these are the addresses. These are the addresses, and here are the contents or the values that you'll be popping and that will be pushing and popping into and from the stack. And we have our flags here: carry flag, zero flag, and so forth, up to df. These are the flags that we have. So for the interface, I think we are now familiar with our interface. So let's now observe this instruction, this move instruction. So our AX, so since these are 16-bit registers, they are divided into two, that is high and low, high and low. So those that are divided into high and low are these four general purpose registers. So from here, DX up to AX, or from AX, BX, CX, and DX, these are the general purpose registers that are divided into high and low. High having 8 bits, and the other side having the low value of the accumulator or base or count or data having 8 bits as well. So this instruction, if you want to run one single step, you click on single step, and you can observe that in AX we now have 1 2 3 4, and 1 2 is in AH, and 3 4 is in AL. I hope we are together here. Nyasha is saying yes sir, yeah. All right, that's fine. So that's what we have for the move instruction. We have moved 1 2 3 4. So let's observe if we just say 1 2. I am always making this silly mistake of trying to edit the code while in emulation. Let's just say 1 2 7 8 is decimal. I don't know if it's going to be moved as it is. So you see 1278 in hexadecimal, it's 04FE. So it's this value is converted into hexadecimal and it's moved into AX. Moved into AX. Gangster, there is not to kunzwisisa kana kawan. Paka shut up. All right. Can you tell me pa muri kuvarwa ndepapi? Tinyatso pabata ipa. Muri kuvarwa ndepapi? Mavarwa kubva patatanga here kana kuti toita sei? Because I am ready to start from scratch. Kuti kubva pamatarasikira totangira ipa. Vari kuvarwa nyatsotaura pamuri kuvarwa chapcha. I don't want to kutaura using the microphone. Can use the microphone. We are writing code. Yes. Okay. I'm in, but confusion and debata kubaba pikutanga chaipo tanonoka kupinda. Okay, kubaba variable declaration hapana chandazombobata. That's fine. Okay. Vasurunzisa vese nyorai zvamusurunzisa tione kuti tingazviita sei. Nyorai tione macomments ayo. Ye pavariable apo kubva pamaregisters apo. Munashe takawira hanzi pavariable hanzi maokover. All right, variable declaration. Okay, that's fine. Okay. All right, let me close my emulator I think most of us are facing challenge on variable declaration. Variable declaration, I think I made a mistake here. It's supposed to be variable name first, and then we define, we put value. I'll just repeat on variable here and start afresh so that you all understand what we are doing here. All right, our lecture ratangana 8:45 and chatuzombo delay kuti vamwe vapinde saka in terms of time, next time I guess you'll be here in time. But don't worry, what I will do is I will upload this same lecture on YouTube so that all those who are pinned late, they will start the same lecture and enjoy whatever that we have done before Mapinda. So let's start. Right, enough comments, I'm enjoying them, but kana muine zvimwe zvamuri kuvharwa nazvo, just type in so that tinozvikava amuende musina kunzwisisa. Right, let me start again now. Let me start again from new. I don't want to save this one. Right, so I will start with a comp template as well. I will start to add my code. Somebody was asking, tukumbonyora code yechi. Code ya tukunyora apa, tudangonyora code yeku move a certain value into a certain register. A register is a memory, is a storage address, or it's a memory address that is within the microprocessor. That's a register. So what we want to do, we want to move a value that is 1, 2, 3, 4 into an accumulator register. And the registers, we have so many registers, like but I will show you once again. So I will show you everything. Move. Tatitine move instruction. Tine instruction on the move. The move. Let me start again. Okay, that's fine. ORG 100XH. It tells us the first address where the first instruction is going to be stored. So ORG, it tells us the origin, that is the first instruction, this instruction that we're going to write here, move AX, comma 1, 2, 3, 4 H, right? We are moving 1, 2, 3, 4 H into accumulator. So this instruction is going to be stored on address 100H. That's what Wesley is asking. Could ORG in the way? I'm happy with wanzwisisa, and you observe as we emulate kuti this instruction is going to be on address 100H. Right, that's fine. So we now understand this. So let me just put a comment there to say ORG, right? 100H is the address for the first instruction in our code. So this instruction is going to be let me just maximize so that you can see. Right, so this instruction is going to be stored at address address what? 100H. Right, so this value is the one that we're going to move to AX. Okay, we will get to the variables like what other guys are saying. So we emulate. If we emulate, you will see that this one, this instruction, I will call it this instruction today, but it's not an instruction. This is a directive. This is a directive. It's not an instruction. That's why it's being skipped by this yellow line. This yellow line starts from the first instruction. So this instruction is the one that is going to be executed. and this instruction is stored at address 100h. Why do we say 100h? So if we write another instruction below this, it's going to be stored in 102, because this is 16-bit, therefore it takes 2 memory addresses. I guess you're getting this, right? So if you emulate this, let's say single step, you observe that this instruction is going to move 1 2 3 4 into AX, which is that one, and the address of this move AX 1 2 3 4 H is stored at an address 100, which is pointed to by instruction pointer, which is 100, If we change to say ORG 3, it means instruction pointer will point at 103. Right, let's now run the instruction and observe 1 2 3 4 going into AX. Single step, tap 1 2 3 4 is moved into AX. Let me check if we are all understanding now. Are we still together, ladies and gentlemen? Pano vari screenwriter say, hanzi chi screenwriter say, hamusiri kuona screen. All right, let me stop sharing and share again. Right, mane screen rangu. Please indiudze uite zvokutaura, because my comments enyu kana ndika maximize I cannot read them.
All
right, that's fine, thanks. Saka ndiri kuti tanzwisisa here pamove instruction. Okay, fine. Right, and that's fine. I feel happy for that. Let me now maximize that. Right. Saka tanzwisisa move instruction. Taona kuti data redu raenda una 1 2 3 4 waenda una AX. That's fine. Tovhara iyo. Takuchiti susu. From our interface. This is our interface. Tati susu ndikaclicka pakanzi screen up. Ndikaclicka pana. Screen redu iri ndo rinobudisa output. This is the screen that gives us output. And then source, it opens this source code. And then reset, reset kuti start from afresh, or it's more like reloading. Then here we can see we have memory. Let me open it. You can see this is our random access memory. Those zvakaita izvo RAM. Kana tikada kuona list, so you can observe kuti izvi zviri apa izvi, this is our RAM, right? And this is exactly what is being displayed there. So we normally don't need to open this, since we already have our RAM running here. So you can observe kuti 100 uya ushu the address iye ku RAM ndokwaenda instruction yedu, because the next instruction to be executed is stored in random access memory. So the RAM is this one. You can see all these. So let me say this. These are the addresses. It's 012 38 no addresses are. But now if we go to our address here, you observe tinobva tauya panapa, and ipapa ndopaenda instruction yedu iyi ina 1 2 3 4. As you can observe 1 2 3 4 is dziri panapa. So ndopane instruction yedu iyi. Mukono kuti that's where we have blue highlighting color. It's highlighting our instruction. So let me close our memory there. Then tikati tine variables. but here tikarivhura hatisi kuona kana variable, handiti ndizvo? Hatisi kuona kana variable. Hatisi kuona kana variable. So let me declare a variable here. Rinonzi Shexa. Oh, I keep on making this mistake. Let me declare a variable here. Rinonzi Shexa. Shexa, you can declare any variable with any name, and this is a word. I'm defining a word and I'm giving it value, which is 1 2 3 4 h, like this. So if I emulate it, let me check if it doesn't have error. Right, that's fine. So is this a variable? Let me check. Right, we now have our variable here. This is our variable name and the value. If we have more than one variable, you will see that we can have, let me declare another variable 2, and this is a byte, d byte, define byte, and I will give it 1 3 h, and then emulate. You observe that if we check the variables that we have 2 variables. So this is a variable called Shexa, and this is variable 2, and then 13 and quad 3h, and it's in hexadecimal. If you want to change maybe to binary, you can observe that the values are now in binary. So that's these are our variables. And then we have debug. You can see all those things. You see here we have all those things. Now what I want you to observe is this. I want you to observe this. Tamboti ORG, this 1 2 3 4 is going to be at address 100. Now this one is going to be the 1/800 address, and this one goes to 102, and this one goes. So you will see that this instruction Shexa define word 33333h is at this address, and if we say next, you observe that this address, this instruction is at address 10102, and then this one is now at address 0106. Why 06? Because it takes 2 memory addresses. This one takes 1 memory address. So that's what we have. That's what we have. I hope we now understand the variable. Those who were saying we are not getting what you are saying on variables, are you now understanding variables or what I was illustrating? We have a complete lecture working on variables, so do not worry about these things. Did you understand all the things that we have done so far before we get into memory?
Yeah, as we did.
Right. Thank you, Alan. I normally do not want to rely on only one person. Yes, tazubata munashe tazubata. Right. I'm happy. Understanding really important. Zaita, yes. Right, that's fine. So let's now have another instruction. Let's have another instruction. So let's close this emulator and delete this. If you want, you can save this file and start a new file, but I do not want to save it. I don't want to save it. I just want to create a new one, and it's a template, using comp template. Right, this time we want to deal with memory, but the same instruction, which is move. We're still using move. So we are moving 1 2 3 4 to a memory address, which is 105. So let me just say 0105 hexadecimal and close here. then the value that I'm going to move is 1 2 3 4 hexadecimal. So this is the same instruction, nothing changes, nothing special, nothing changes. Right, I'm recording it. I will post it on YouTube. Somebody is asking, are you recording? And Ruto recording. But if maybe I can record it here so that you can see the counting of seconds there. Right, so check it. Right, let's now emulate this code. If we emulate this, now what we want to do is we want to open the memory, but this is the memory that we have here. Let's just open it in this way, and then here it is a list. Right, so the address that is 105 is this one. So you can see that 1 2 is exactly at 0105, and then 3 4 goes to 0104. So this is 8 bits and this is 8 bits. These are 8 bits, 8 bits. So 1 2 and 3 4 moved successfully. So I'm sure that everybody is now understanding the interface. Every corner of the interface is now understood by everybody, if I'm not lying, and I can confirm this from all the comments that you are posting in the public chat. So that's it. I am going to post. So what I can do is I may post a YouTube video about the move instruction so that you can follow it. We can do it together on a certain day, but you can still do it at your own time. That's what I like the most. I like you to do it at your own time, at your own spare time. So that's it for today, ladies and gentlemen. I hope you have enjoyed it. If you have questions, please ask now. C1711312, sorry for the lagging network. I hope you enjoy the lecture when you see it or available on YouTube. Right, so thank you, ladies and gentlemen. Please make sure you watch the videos that I have provided you with the links in the public chat. I will paste them again here. Let me just paste them again. Let me paste them once again in the public chat here. Yes, here are the videos. Watch them, accessing memory, doing all those things. And most importantly, do the following: like, comment, share, and subscribe. Thank you very much. Enjoy the rest of your day. Goodbye.